Over 252 million years ago, Earth experienced the darkest moment in its history of life. It wasn't caused by a massive asteroid nor by a clash between ancient creatures, but by a smoldering nightmare rising silently from deep within the Earth, only to erupt without warning. This event wiped out nearly all life from ancient forests to the deepest reaches of the ocean. It is estimated that 90 to 95% of all species vanished, a number almost beyond imagination. In that instant, Earth was no longer a cradle of life, but a vast graveyard. This raises the question, what really happened? How can modern scientists rewind time to lift the veil on the darkest era of the planet's past? And could a similar catastrophe happen again in the future? Before the disaster struck, the blue planet had gone through a period of extraordinary prosperity during the Paleozoic era. All landmasses at the time had merged into a single supercontinent, Pangaea, stretching from the icy poles of the north to the blazing equatorial regions. Surrounding this vast landmass was the immense Panthalassa Ocean, where ancient ocean currents nurtured a vibrant and diverse marine ecosystem. As glaciers receded, the climate became stable and warm, allowing life to flourish. Primal forests rose to dominance, where giant ferns grew among ancient conifers, and thick underbrush covered the untamed land. Though flowering plants had not yet emerged, gymnosperms had already taken over the landscape, greening highlands, valleys, and mountainsides. Amid this rich vegetation, insects thrived in both number and size. The prehistoric dragonfly Meganeura, with a wingspan of nearly 70 centimeters, soared like tiny aircraft through the primeval jungle. Beneath the ocean's surface, another world thrived. Primitive sharks, ancient bony fish, and ammonites, with their exquisite spiral shells, wove a vivid and dynamic tapestry of life. Back then, Earth was a paradise, mild climate, stable geology, balanced ecosystems. All signs pointed to a thriving biosphere that could last millions more years. But no one could have foreseen that in the blink of geological time, everything would collapse. At the end of the Permian period, around 252 million years ago, Earth suddenly entered a phase of extreme climate change. The shift from humid to arid environments happened so rapidly that ecosystems had no time to adapt. Global temperatures spiked, especially around the equator, where land surface temperatures reportedly reached an unthinkable 74 degrees, hot enough to incinerate all higher forms of life. Pangaea, with its unique terrain formed by the unification of all continents, caused vast areas to become arid and nearly uninhabitable. A massive mountain range stretched across the supercontinent, blocking rain and wind, creating dead zones where droughts were endless and merciless. In such conditions, mere survival was almost impossible. And then tragedy struck. The Permian-Triassic extinction event, often referred to as a slow-motion apocalypse, not only devastated the biosphere, but also left a deep scar in Earth's geological history. But what was the real cause? An asteroid? Or something even more terrifying? Today, scientists believe that the main cause lay in massive geological tectonic activity. Scorching magma streams erupted violently from deep within the Earth, covering hundreds of thousands of square kilometers in what is now Siberia. These eruptions released vast amounts of greenhouse gases such as CO2 and methane into the atmosphere. The greenhouse effect sent the planet into a relentless fever. Many marine regions became deoxygenated and acidified, and ancient coral reefs, once underwater paradises, turned into lifeless hellscapes. The problem is further complicated by the fact that most of the physical evidence from that era has been destroyed by millions of years of geological upheaval. However, thanks to modern technology, especially isotope analysis and climate modeling, scientists, including figures like Dr. Ethan Caldwell from the Institute of Geoarchaeology, have begun uncovering the first clues. They are gradually peeling back the layers of one of the greatest mysteries in Earth's history. Many hypotheses have been proposed to explain the mass extinction event at the end of the Permian period, a biological catastrophe of global scale. Among them are studies that suggest the possibility of a massive extraterrestrial object, possibly even larger than Mount Everest. It could have been a meteor or asteroid, an uninvited visitor from the distant cosmos that crashed into Earth, triggering an unprecedented biological annihilation. However, from a different perspective, many scholars argue that the catastrophe was not a sudden explosive moment. On the contrary, it resembled a slowly spreading curse, a chain of events that stretched across centuries, even millennia. According to this hypothesis, the death of nearly all life on Earth was the cumulative result of multiple factors. Extreme climate change prolonged massive volcanic eruptions and disruptions to oceanic circulation. All of these combined into a geological death spiral, slow, brutal, but unstoppable. A bolder hypothesis has also been proposed. The disaster may have originated from cosmic radiation caused by a nearby supernova explosion. If true, then Earth was struck by a wave of death from the deep reaches of space radiation, strong enough to destroy the ozone layer, alter the climate, and cause mass genetic mutations. Regardless of the exact cause, the rapid advancement of stratigraphic simulation and modern fossil analysis technologies has allowed scientists to significantly shorten the estimated timeline of the extinction event. From an initial assumption of millions of years, they now believe it may have occurred over just 8,000 to 100,000 years, a blink of an eye, in Earth's 4.5 billion year history. While such a span may seem long to humans for the planet, it was merely a moment of silence between two heartbeats. Yet to draw any definitive conclusions, researchers still require solid experimental evidence. Unfortunately, within the ancient sediment layers preserved from the boundary between the Permian and Triassic periods, geologists have uncovered mysterious samples, strange carbon structures known as fullerenes. Fullerenes are carbon molecules with a structure resembling a soccer ball, composed of dozens of carbon atoms arranged in a perfectly symmetrical geometric pattern. What makes them special isn't just their shape, but what lies inside. Scientists have discovered rare isotopes such as helium-3 and argon-36 embedded deep within these crystals. These are elements that are uncommon in Earth's crust but are frequently found in comets and meteorites, wanderers from outer space. This discovery is seen as strong evidence supporting the hypothesis that Earth once experienced a catastrophic cosmic impact, a collision that may have triggered the mass extinction event at the end of the Paleozoic era. However, doubts remain. Many scientists believe that if a meteor did strike, it was not the primary culprit of the devastation, but merely the spark, a triggering factor that accelerated a chain reaction of geological events waiting to erupt. From the restructuring of the lithosphere, the acceleration of tectonic activity, to prolonged volcanic eruptions lasting for millennia. To illustrate how small modern geological disturbances are in comparison, we can look at the 2011 tsunami disaster in Japan, a clear example of the dangers of tectonic plate movement. Despite its devastating toll on lives and infrastructure, it pales in comparison to the ancient geological upheavals that tore apart continents and scorched the planet. That event was but a soft signal, like the brief vibration of a phone when a message arrives. Returning to the Paleozoic era, before the Great Extinction, Earth was composed of two massive supercontinents, Laurasia in the north and Gondwana in the south. The planet's surface at the time acted like a thin, fragile skin floating atop a churning ocean of magma, not unlike a giant iceberg drifting slowly across the Arctic Sea. When a force strong enough rose from deep within, that crust would crack, deform, and potentially collide uncontrollably, initiating a chain of destruction that could not be reversed. Though Earth's tectonic plates are massive and interlocked like ancient puzzle pieces, they have never been truly still. Subtle, ceaseless movements within the Earth's mantle create massive rifts, channels through which magma rises from the deep. And when those fiery currents awaken, they do not come alone. They bring with them poisonous gases, fine ash, and sulfuric acid, spreading throughout the troposphere and plunging the entire biosphere into an unprecedented crisis. One of the most widely accepted hypotheses in the scientific community suggests that it was the violent volcanic eruptions in the Siberian region that triggered the greatest mass extinction in Earth's history. In this area, geologists have discovered an enormous basalt formation known as the Siberian Traps, a volcanic plateau spanning a region nearly 2/3 the size of modern-day Europe. It is believed that the Siberian traps are the remnants of repeated violent magma outpourings powerful enough to wipe out almost all life at the time. According to scientific estimates, the cumulative force of these eruptions far exceeded the infamous 1980 eruption of Mount St. Helens. In fact, they were 4,000 times more powerful than the Yellowstone supervolcano, long considered the most dangerous natural threat in modern history. If you imagine this region situated in North America, the entire United States would be submerged beneath a lava layer 3 times the height of the Empire State Building, a scene reminiscent of the apocalyptic movie 2012. But this was not science fiction. This was a real event in Earth's history. What's astonishing is that these eruptions didn't erupt violently all at once. Instead, they occurred steadily and continuously, quiet but massive over hundreds of thousands of years. During that time, our planet transformed into a fiery hell, a suffocating dark realm where all life forms struggled under the weight of the Earth's fury. Near the eruption's epicenter, the destruction was beyond imagination. The sea of fire formed by molten lava spread slowly but irresistibly, like Earth's hot blood pouring out. It incinerated all life in its path, sweeping everything away with temperatures reaching 100–200 degrees Celsius, far surpassing the melting point of any modern crematorium. But perhaps many organisms never lived long enough to burn, for death struck before the flames arrived. Massive wildfires ignited by subterranean heat tore through forest ecosystems. Vast vegetation was incinerated, the atmosphere filled with ash and toxic compounds. Based on surviving fossils, scientists confirmed that even once thriving species like Gorgonopsids or Thrinaxodon could not escape this tragedy. Even regions far outside the direct impact zone weren't spared. The relentless lava outflows altered the climate in irreversible ways, not because of the fire itself, but because of what it carried. Throughout the eruption period, the volcanoes released immense amounts of CO2 dust, sulfur, chlorine, and other toxic substances into the atmosphere. The total mass of material ejected into the sky is estimated at over 200,000 gigatons, more than 1,000 times the weight of Mount Everest itself. Each of these toxins on its own would be enough to cause the collapse of a global ecosystem, but when all appeared within the same period, a resonating effect occurred, and destruction became inevitable. Just when it seemed that things had reached the bottom of the catastrophe, fate took another devastating turn. The eruption zone happened to overlap terrifyingly with underground layers of coal and flammable materials. When magma reached them, it triggered a chain reaction of widespread fires, plunging Earth into a biological twilight. What stunned scientists most was the speed. The event did not unfold as a slow, linear progression, as previously assumed. On the contrary, it advanced in what scientists call extinction pulses, brief but catastrophic bursts in which countless species vanished almost simultaneously. If someone were unfortunate enough to be transported back to that era, their first sensation would be utter shock, from the heat exceeding the tolerance threshold of any living creature, and an atmosphere so thick with ash that every breath would feel like a blade slashing through the lungs. According to scientists, at the end of the Permian period, Earth underwent the hottest climate in its entire history. However, the volcanic catastrophe in Siberia pushed the planet far beyond its normal temperature limits, turning the surface into a gigantic steam oven, where the heat not only scorched flesh, but also strangled life itself. The combination of toxic gases and ash from incinerated forests created a permanent haze, a thick blanket enveloping the entire atmosphere. It trapped heat inside the planet, causing surface temperatures to soar beyond 50 degrees Celsius. For comparison, the current global average temperature hovers around just 17 degrees Celsius, a modest figure next to the blazing inferno of that era. In equatorial regions, naturally Earth's hottest zones, estimates suggest temperatures may have reached unimaginable levels where no living being could survive more than a few hours. In modern times, we've witnessed deadly heat waves like the summer of 2010 in Russia, a temperate country famed for its cold winters, when July temperatures peaked at 53.5 degrees Celsius. That event claimed around 56,000 lives and incinerated over 86,000 hectares of forest. These figures underscore a grim truth: in such extreme conditions, even the most intelligent species on Earth is but a fragile organism struggling through the tragedy of survival. But death in that age did not come solely from fire. Prolonged high temperatures created a global drought vortex, pushing the planet into an unprecedented state of dehydration. Fields, forests, and wetlands all withered away, revealing barren, lifeless soil. Some studies suggest drought was the primary killer, the factor responsible for the mass death of terrestrial vertebrates more than any other cause in that extinction event. And yet the nightmare still wasn't over. Even those few organisms that found refuge from fire and drought couldn't escape a more insidious threat: poisonous gases. Gases from deep within the earth, from volcanoes, and from the decomposition of billions of carcasses, all combined engulfing the biosphere. The atmosphere grew so dense and suffocating that oxygen levels dropped to around 15%, far below the minimum threshold needed for large animals to breathe. In prehistoric times, Earth's atmosphere once contained up to 30% oxygen, double today's level. Ancient species accustomed to oxygen-rich environments suddenly faced a suffocating, murky, and toxic world. Most could not adapt and quietly vanished from the evolutionary timeline. But even if they survived fire, drought, and poison, another menace was silently spreading across the planet: lethal radiation. The intense eruptions in Siberia released vast quantities of halogen gases into the stratosphere, devastating the ozone layer, Earth's shield against ultraviolet radiation. As a result, UV levels on the surface skyrocketed. In equatorial zones, UV radiation may have exceeded normal levels by 400%. In polar regions, it was possibly up to 50 times higher than today. Merely standing under the sun back then for a single day would have been equivalent to spending 4 days non-stop in an industrial-strength tanning chamber. This radiation level was powerful enough to destroy nearly all living cellular structures, and surviving biological traces confirm this. Some plants were damaged so severely that they developed bizarre, never-before-seen mutations. This is believed to be the direct cause of the complete extinction of many ancient tree species, trees that had survived hundreds of millions of years of evolution. Even in the deep ocean, seemingly the last safe haven, things were perhaps worse. Sea surface temperatures rose to levels comparable to heated industrial bathwater, boiling the marine world alive. Aquatic life forms had to endure not only the heat but also multiple new threats. Deoxygenation increased UV penetration through shallow waters and chemical transformations that poisoned entire ecosystems. Earth at that time was no longer the blue planet. It had become a colossal killing machine driven by the ancient laws of nature. Laws that are unyielding and emotionless and leave no room for the weak. The phenomenon of ocean acidification has far surpassed anything previously recorded in geological history. The pH levels in seawater dropped abruptly, creating an extremely hazardous and toxic environment that persisted for an extended period. In many marine regions, the level of acidification spiked over 30% beyond what is considered dangerous by modern standards. This meant that even the hardiest marine organisms no longer had anywhere to hide. By this point, after surveying nearly half a dozen methods of destruction from Earth's darkest era, many might think the tragedy should end. But reality is always colder and more brutal than any imagination. Another terrifying phenomenon lurked behind the scenes: the global hyperstorm. Though it currently exists only in theory, scientists assert that if ocean temperatures were to reach 50 degree, a type of cyclone unlike anything in Earth's history could form. And while average global temperatures during that time may not have reached such extremes, localized hotspots could have easily done so. According to simulations, this hyperstorm could expand so rapidly that in a short time it would cover half the territory of the United States. What frightens people most is the wind speed, potentially exceeding 800 km/h, a number never before recorded in the history of meteorology. With such force, it could flatten entire fortified cities and uproot ancient forests that had stood for millions of years. At the heart of such a storm, atmospheric pressure would plummet so sharply that humans would feel as though they were standing over 3,000 meters above sea level. Yet all sensations would become meaningless, because nature's wrath would erase all life before you could even comprehend what was happening. The Permian period, the final chapter of the Paleozoic era, closed with a horrifying finale surpassing all nightmare scenarios ever told. The extinction rate reached an unimaginable scale. 96% of all living organisms were wiped out, with 57% of biological families vanishing entirely, leaving behind no descendants whatsoever. You might think that number sounds exaggerated, but place it beside the second most severe extinction event in history, which erased only around 27% of biological families, and the vast gulf becomes unmistakable. Even if you were to have the figures, the Permian catastrophe would still remain unimaginably destructive, especially when compared to the event that wiped out the dinosaurs, which only caused about 17.7% of families to disappear from the planet. But to pinpoint exactly when the Great Dying occurred, we must look far beyond the limits of clocks, human history, or recorded chronology. In geology, time spans hundreds of millions of years. To measure these obscure milestones, scientists have developed a specialized system, stratigraphy, based on the principle of formation and layering of rocks in the Earth's crust. Each rock layer corresponds to a specific period, like a page etched deeply into the body of the planet. One of the pioneers of stratigraphy was William Smith, an English surveyor. During his explorations across the United Kingdom, he discovered that fossil-containing rock layers were always arranged in a specific chronological order. After 15 years of tireless study, he published the first comprehensive geological map in 1815, a work not only scientifically accurate, but so visually beautiful that it astonished the academic world. This work sent shockwaves through the geological community and deeply inspired future generations of scientists, among them the Scottish geologist Roderick Murchison. He applied Smith's method to study the rock layers of the remote Ural wilderness in Russia. There he discovered extraordinary fossil evidence pointing to the existence of a previously unknown geological era. Based on the specimens collected, he and his colleagues decided to name that period the Permian. It became a clear boundary between two great eras, the Paleozoic and the Mesozoic, where the incision in geological history is etched as sharply as a blade of fate. Right at that dividing rock layer, signs of mass extinction appeared like a fossilized storm, leaving behind haunting scars that would linger for tens of millions of years. Though life was not completely wiped out, it was forced to restart from zero in a world vastly different, harsher, and full of new challenges. Earth's history is a strange cycle of reincarnation, where death is not an end, but a gateway into a new journey. Forests once buried during the Carboniferous period became coal mines that would later fuel human civilization. The fish carcasses that piled up on ocean floors during the Permian extinction were transformed into oil reserves, the very lifeblood of humanity's industrial age. No one can predict disasters of such magnitude. No one can demand an apology from nature. But from the ashes, life rose again, stronger, more adaptable, and more intelligent. That is the eternal spiral of evolution, and there is hope that humankind, with all its intelligence and pride, will still have a place in the next chapter of this planet.